Hello everyone. I hope we all have seen from our previous classes, that is 6th, 7th, 8th and so on, how to take out highest common factor or greatest common divisor, GCD or HCF. So HCF is the highest common factor, which means if I have two numbers, let's say 9 and 12. So for 9 the factors are 1, 3 and 9, and for 12 it is 1, 2, 3, 4, 6 and 12. So in these two, 1 is a common factor and 3 is a common factor. So which is the highest common factor? 3. So that we call as highest common factor. That these things you all know, right? In 6th standard, 7th standard, 8th standard we have read these. So let's discuss today something about HCF itself, and starting with Euclid's division lemma. So Euclid division lemma, we all know what it is, right? In the last class we saw that. And today we'll see about Euclid division algorithm. And two words are common in these, Euclid division, and now we have algorithm, Euclid division algorithm. So what is an algorithm? When I repeatedly use a single operation to solve anything, that becomes an algorithm. So here we repeatedly use this Euclid division lemma to do what? To find highest common factor of two numbers, and that becomes an algorithm that we call Euclid division algorithm. So we know that we can represent any number in the form a equal to bq plus r, right? Let's say a number is there, a equals to bq plus r. We'll take an example alongside this so that it's more clear. Let's take up, I have, let's say 867. So I have to represent 867 as something. We'll see what. So if I write 867, and let's say I have to find HCF with 867 and 255. HCF of 867 and 255. So I can write 867 is equals to 255. I have now divide 867 by 255. What we get? 3s are 15, 1, 15, 16, 6, 1, 6, 7, 65. We get our remainder as 102. So I can write it 255 into 3 plus 102. So that's how we write this, right? A equal to bq plus r. We have seen in the lower classes again. So now I'll repeat this algorithm using what logic? Using the logic that if A is written as bq plus r, then we can say that every common divisor of a and b is a common divisor of b and r. How can we justify that? We have numbers a, b, q and r. This is a, this is b, this is q and this is r. So I'm saying every common divisor of A and B. Let's say 3 is a common divisor. 8 and 7, 15 and 6, 21. Sum divisible by 3. 255, 12. Sum divisible by 3 and 102. Sum divisible by 3 and this is also 3. So every common divisor of A and B, that is A and B के जितने भी common divisors हैं, that are common divisors of B and R. So whatever are the common divisors of A and B are common divisors of B and R. This is what this algorithm uses. Okay. So like here we can write now B is equals to R into Q2 plus R2, let's say. Similarly I'll write here 255 is equals to 102 into 2, right, 204, and we have remainder as 51. This much is clear? Now R is equals to R2 into Q3 plus R4, and this goes on till I get Rx, let's say, is equals to 1. And when I get Rx equal to 1, the remainder above that, Rx minus 1, is the HCF. We'll see this soon. When we'll solve this, you'll get that. So now I write 102, this is equals to 51 into 2 plus, sorry, when I get R equal to 0, I'm really sorry, plus 0. So I get remainder as 0. So what was the remainder here? Is the HCF. Clear? Thank you.